Hello and welcome to another segment of the Coding Week. My name is Farzan Yaz, and today's challenge is to program a word search solver that finds and capitalizes all the words in a given word search matrix. It should be able to find words horizontally, vertically, and diagonally. This tutorial covers the basic building blocks that you would need. Now in this word search solver class, aside from implementing the basic methods to get you familiarized with strings and matrices in Python, we're also going to be implementing this word in row method, which actually finds a given word in the given matrix, but only looking horizontally. The rest is up to you guys. And we also have this matrix.txt file, which is going to be where we're going to be doing our testing. Skipping over the constructor method for now, let's take a look at reverse. This is going to be helpful for finding words that are backwards in the word search. So in Python, let's say you have a string set to Kurius. If you would call the string at 2, this would call the second element of the string. So 0, 1, 2, that will give you R, right? Similarly, you can call like splices of the string. So 2, 2, 5. So it would give you strings from element 2 up to element 4. It doesn't include 5. So it would give us R, 3, 4. It would give us RIU. Now let's say we did something like str from 0 to 2, right? So this would give us 0, 1, so KU. But we could also just take out this 0 and it would be the same thing. It would go from the start of the word up to the second index. So again, KU. We could actually also call elements from the negative index. So let's say we did string at -1, it would give us S. So it starts from -1 at the last letter, and it just works backwards. So S is -1, U is -2, I is -3, and etc. So with this, we could say, for example, -4 to -1. So it would give us -1, 2, 3, 4. It would give us 3 RIU, again, not including this -1 itself. Now we can also add a step to this. So let's say we got str from the beginning of the word all the way to the end. So 0, 1, 2, 3, 4, 5, not including 6. If we were to add a step of 2 like that, it would give us KRU, so every other word. Now putting it all together, we could take our string and say from 0 all the way to the end and give it a step of -1. This would go from the back. It would say SUIRUK, so essentially reversing the word. We could also take this another step further, get rid of the 0 and this 6, and this would do the same thing. So for our reverse method, all we need to do is return the string that we have in the parameter here, ::(-1). All right, that was pretty easy. Now let's take a look at reading files in Python. Now specifically for our purposes, let's say we were given this file, right? And we want to read it and save it in the end as a matrix. So how would we go about doing that? So let's say we have all of these lines. What we could do is save each line in its own element in a list, right? So we would say this line is row 1, this line is row 2, or in Python we would say this is element 0 in the list, this is element 1 in the list, and so on, right? So that's what we're going to do in this read file method. We're going to need to first open the file, read or write its contents, and then close it. Now there's a very easy way to do all of this in one line, which is going to look like this. So we're going to say with open. Now we're going to open our file. So our file is going to be whatever parameter we give it here. And we're going to open it as read only this time. So we put an R. And we're going to open this as, let's give it a name. We're going to say word search, right? Now there are 3 main ways to read the contents of this file. You could firstly do string equals word search.read, and that would just save all of the contents in the file as a single string. Or you could do a line, for example, equals word search.read line, and that would save just, read line, and that will save just one line, or in this case, the first line of the file. And lastly, what we want is, for example, lines equals to word search.read lines, and this will save every line in the file as its own list element. So this lines becomes a list, and every line, for example, in this file is an element in that list. And after we've done that, we just want to return this list. All right, so now we have a list consisting of individual lines from the file. So for example, we would have a list looking like so, right, where this is the first line and this is the second line. There's spaces in between the elements because, like in our case, we're going to have spaces in between the elements in the given matrix. So let's just keep it consistent like that. So these are rows, and we want rows and columns in our matrix so we could look for words. To do that, we're just going to take every line and we're going to split it into lists at every white space. All right, what does that mean? So let's say we have this element 1, that's our whole string. We're going to split it into individual letters and put it in another list, right? So now we have a list containing of 2 lists where those lists are individual letters, right? So if we would think about it like a matrix, it would look like this. This first list is row 1, the second list is row 2, and then we have the first element from both of them making up column 1, the second element from both of them making up column 2. Now this sounds complicated, but it's actually quite easy to implement. Let's take a look at some string methods here. Let's say we have a string set to A, B, C, a tab character at the end, extra spaces at the beginning. All right, now this is a pretty messy string. Let's say we want to clean it up. To do that, we would just do string.strip, and that would give us a new string A, B, C, like that, right? But that's not quite what we want, right? But then we could again just do string.split. Now that would give us what we want. It would split the original string into list elements at the given character. Now we gave it no character, so it's going to be splitting it at every space. So it would give us a list with A, B, and C. All right, so that's what we want. So let's get rid of all that. All right, now to do that for every element in the list, we're going to need to iterate through the list. So we're going to need a for loop. So for I in range, and the range is going to be 0 up to the length of the list. We don't need to include the 0, right? And then we could save the string or the line at that element by doing, for example, line is list at the index I. So for example, here we would have this entire string 1 with the spaces. And we're going to want to change that list at index I to line.split, right? That's all it takes. Then this again splits the string at white spaces. Before we move on to the next method, let's quickly talk about iterating through a matrix in Python. So matrix in Python is just a list containing other lists, right? So this is just a normal list, right? Like 1, 2, 3, 4, 5. A matrix would be a list containing lists, and those lists contain the elements that you want, right? So list 2 would look something like this, right? You could think of it as a matrix looking like this. To iterate through the elements in this first list, like a normal list, you would either do for element in list, or you would do for I in range, and then put the length of the list in there. This one is for when the index doesn't matter to you. This is for where you actually want to use the index every time, right? So you could combine these two to iterate through the elements in list 2, right, or in the matrix. So for example, you would do for element in list 2, and then you would do for sub element in element, right? So now it goes through every element in list 2. So let's say it goes to this first list, and then for sub element in element. So then it goes through 1, 2, and 3. And then it goes to the next list, goes through 4, 5, 6, next list 7, 8, 9, right? And then again, this is for when you don't need the index. Or you could do for I in range length of list 2. So in our case, that's 3. So it would go up to 0, 1, 2. And inside here, you could do for j in range length of I. Right? That took me a second to come up with. So basically, for I in range, I would be this first element, right? So the whole list. And then j would be in range length of I. So the length of I is 3 here. And then j would be iterating through these elements. So 1, 2, 3. right? So this is for when you need the index of these elements, right? So let's say you wanted to go through every row, right? And for every row, you could just do this. You're just going through every row. For every column, for example, you want to go through column 1, you could do for I in range this. This goes through every list, so every row, and you would just look at column 1, right? So instead of doing that other for loop, you could just say list 2 at I, but then the column would just be 0, or the second column, or the third column. You could also say for element in list 2, and then let's say you want to take a look at only the first column. You would do element at 0. So it goes through every list here, every row, but it only looks at the 0 index of each row, so the first column, right? If you want the second, you would just do 1, third, you would do 2. Right? So that's how you can look through the elements in a matrix and iterate through them. All right, now let's take a look at the word in row method. It takes in self, of course, matrix, and word. So we have the matrix all set up now. We have rows, we have columns, and now this method is gonna look in every row, and it's gonna tell us if the word that we have given it is there or not, and if it is there, it's gonna return the row index and the element indices. Right? So to do this, we're going to take every row, we're going to convert it into a single string. We're going to look for a word in the row string, and we're also going to look for the reversed version of our word in the string, and then we're going to return the row index and element indices, or we're going to return false if it's not in the row. So we need to iterate through every row in the matrix, or in Python, we need to iterate through every element in this matrix list that we have. So to do that, we could just say for row in matrix. Let's save the row index just in case we need to return it if we find a word. So let's do a row index equals matrix dot index row. So this tells us what index the row is at inside of this matrix list. And then we could create a temp string which joins all the elements inside of that row, right? So if we have O, and E, it would join all of it into just one word that says 1, right? But we also need to give it a separator, so what goes between every letter. We want nothing to go in between the letters, so we just give it an empty string, just like that. Now that we have our entire row saved as a string in temp, we can just look inside of that string using Python's find method and save the index where the word starts, right? So we could say our start index equals to our temp string, and we just do dot find, and we're going to give it our word, which we put here. The thing about the dot find method is if it finds the word, it's going to return the index of the first letter where it found the word in the string, or it's going to return -1 if it doesn't find a word. So if it doesn't find the words, or if start is less than 0 or equal to -1, whichever way you could do it, we're going to look for the word in reverse, right? So we're going to set start equal to something new this time, and we're going to say temp dot find again, but instead of word, we're going to take that method we made earlier, reverse, and then we're going to put word in there. So here we look for the word. If it doesn't find it, we're going to look for the reverse of that word. All right, so at this point, to check if we found the word or not, we can just say if start is greater or equal to 0, or not -1, we have the starting index of it. So the ending index, it would be some basic algebra where you would have the ending index being the starting index plus the length of the word -1. This -1 is because indexing starts at 0, but the length of the word starts at 1. Okay, so now we have the start and ending indices of the word, and we could just print the word was found in the matrix, right? And we could return the row index. We can return the starting index of the word and the ending. So now let's say it went through every row in the matrix and it did not find the word. So at this point, it would finish the for loop and exit it. And then we would just say word not found in the matrix, right? And we would just return false. Going over the code again, we go through every row in the matrix. We save the row index. We create a temporary string variable that joins all the elements in the row, so all the letters in the row. We look for our word in that string that we just created. If we did not find it, we look for the reversed version of it. And in the end, if it found any word, either the reversed or the normal, it would print the row index, starting index, and the end index of the word. Otherwise, we did not find a word. Now, the challenge also requires you to capitalize the word after you find it. If you wanted to just capitalize a single string, you would do, for example, string.capitalize. Easy as that, right? But maybe you're trying to capitalize substrings of the row. Substrings you could find like so, like we discussed, or you could capitalize individual letters in the matrix. That's what we're going to be showing as an example today. So our cap word method, it takes in the matrix, it takes in the row, and then it takes in the starting and ending indices of the word inside of that row, right? So we're going to be iterating through these indices from start to the end. So to do that, we would need a for loop for I in range start to the end. Now this end, we would have to add a +1 because the range is not inclusive. And then we would save our letter as the matrix at our row at index I, right? So that's our letter. And then we would simply substitute that. So matrix to row at I, we're going to change that to the letter dot capitalize. Now we can also implement a print matrix method to print the matrix into the terminal. We could use this dot join row method that we used before. We could actually just copy paste this. Okay. And we would take for a row in matrix, so iterating through every row in the matrix, we would print every row in the matrix. And we would add a separator in between them. Let's just add a space, right? So it looks like what we have in the file. And that's it. All right, so after we're done looking through the matrix and capitalizing words, we need to write our new matrix to the file again. So to do this, we could do it multiple ways. We could write line by line or letter by letter even. But in this example, we're going to try to take all of the elements inside of the matrix, concatenate them, and then push that entire string to the file. Okay, so to do this, we're going to need an empty string to start with, which we'll be adding to. And then we're going to go through every row in the matrix like we do every time. And we're going to take our string and we're going to add to it what we have over here. We're going to add that. And we're also going to, at the very end, add a new line character. So it goes to the next line when the for loop iterates to the next row. Now after this for loop terminates, we have everything we need in the string, so we're just going to write it to the file. And to do that, like before, we're going to do with open, we're going to do the file, and this time instead of read, we're going to write to it, so W, and we're going to name it word search like before. This time instead of read, we're just going to do dot write, and we're going to give it our string. Alright, so that's everything we need for a very basic word search solver, which looks only in the rows and only for a single word at a time. You guys would need to look for multiple words in the rows, columns, and diagonally. This code also isn't very keen on the boundary cases. You guys should probably take a look at those further, like for example, if the word ends on the edge. But let's just test what we have. Let's create inside of the constructor a self.matrix variable, and the input of that is going to be whatever read file gives us, right after read the file. And then we're going to take the lines to matrix method we made and give it self.matrix. Okay, so here read file, it reads the file that we give it. And save the lines as the matrix, and then it goes to the matrix and takes every line and turns it into columns as well. And then we would also need to do the self.word in row, give it the matrix, and give it a word. Let's say Kurius. And we would need to save the output of this into 3 separate variables. So we're going to have the row index, we're going to have the starting index of the word, and the ending index of the word. Okay, and then we can print the row start and end just for our own reference. Now we need to make sure that it didn't return false before we move on. So we could just pick any of the variables, and let's say if row is not equal to false, we would continue. We would say self.capitalize the word. We would give it self.matrix. We would give it the row start and end. And then lastly, we would write to the file. The file name is matrix.ta. Oh, I guess we could just give it the same file name we gave it before. And the matrix is self.matrix. Okay, perfect. So let's go to the bottom. Let's uncomment this code, which calls the word search solver with the matrix.txt file. And save that, and let's run it. Let's see what we get. So let's take a look at matrix right now. Nothing's capitalized. Okay, and we run it. 238. So row 2 starts at index 3, ends at index 8. So let's go 0, 1, 2, 0, 1, 2, 3, and there it is. It's been capitalized. Kurius. Perfect. All right, it works. All right, let's also test out the printing method just for fun. Matrix. All right, let's run that again. All right, very nice. It printed the whole matrix, and Kurius is capitalized. Perfect. All right, guys, that's about it for this tutorial. I hope you learned something new, something valuable, and I wish you good luck on this challenge. It's a tricky one when it gets to the diagonal portion of it. But yeah, thank you so much for watching, and have a good day.